Now I'd like to show you how to install a knife in the tissue slicer, the 7000 SMZ2. Here you see one of the ceramic blades in its protective holder, which prevents you from cutting yourself, which usually will generate some paperwork and some embarrassment. If you remember correctly, this screw over here is oppositely threaded than normal. So, and this one's normal. So you loosen the screws. There's a washer and a little nylon washer under there, under the steel washer. You loosen this to the point where you can slide it into place. If you don't have these loosened enough, it's a little bit more difficult. There is a cutout on the knife holder. Once it's in place and it's butted up against the rear of the knife holder, you can tighten it down. And yes, even I have to think about which way that's used to tighten this screw, and because it's opposite, so it's turning to the left, you want to make sure that the blade is on the little shelf. There we go. It just dropped into place. So it's lefty-tighty on this one, righty-tighty on this one, and once the blade is mounted, you can remove the cover. So what we're going to do now is we're going to put the OptiCal system in place. So again, the bath is in the load position because you want plenty of clearance between everything in the knife. You don't want to dull it. You plug in the OptiCal system. Select blade alignment. I don't know if you can see that. Let me move this back. There we go. Let's go back to menu. Select blade alignment. Enter. Get the manual and adjustment tools. Fit the alignment device and a new blade, which I've done. Return. If you press return, it'll exit you from this operation, or if you hit slice, it will continue. It asks you what kind of blade that you put in there, a stainless steel blade or a ceramic blade. In this case, I put a ceramic blade in, hit enter. Now it's going to move the blade to alignment position. So go back a step, you press return, press slice to continue. So now the system will carefully move the blade to alignment position. It will raise the stage, so the blade is scanned by the optical scanner. Okay, so first thing you want to do is loosen the screw on the bottom so it's snug but not really loose. These two have to be fixed tight. This set screw or grub screw is going to push up and down on the blade holder assembly, allowing it to properly align. I will mention, unfortunately it doesn't come with the system, but this requires a 3mm hex key that would go into that set screw or grub screw. So now we're just going to simply press slice to vibrate, and it's going to measure the Z alignment of that blade. Now, I know I've already pre-aligned this, but I know from experience it only will take very small increments to change that. Now that was maybe an eighth of a turn. I'll hit slice again, and now you see that this is up to 0.9 microns. And you always want to shut it off when you're doing this alignment, because you don't want your Allen key to go careening back and forth inside the little hole there. So you make a very tiny adjustment, let it oscillate. Okay, I removed some of the Z-axis deflection to 0.7 micrometers now. If you find that the numbers are getting larger each time you test it, it means you may have gone past the correct point and you need to sort of back off a little bit. Okay, almost at 0.2. It's between 2 and 3/10 of a micron. Okay. For all intents and purposes, you can play with this as long as you like, but I find that getting it to 0.2 is quite sufficient, and you don't want to take up your entire time fiddling with the blade adjustment. So it says now return to exit, so you press return. It asks you, do you wish to exit the blade alignment routine and remove the alignment device? Hit return to go back to the previous step, hit slice to exit. So now it's lowering the stage. And it will retract the arm. And you can carefully remove the OptiCal system from the instrument. At this point, I would either put this blade cover on, or I would use this magnetically held blade cover to protect yourself from injury. Oops, I was already in home position, excuse me. I'll wait till it's done. Now I'll hit load bath. So it goes all the way down. Okay, so now I will carefully slide the tray into position. Now I'd hit load bath and allow it go to the home position. And now you're ready to mount your specimen and load buffer in this tray. Put some ice in this outer tray if you so desire. If you put ice in there, make sure that your meltwater clamp is closed. Again, once the ice melts, you want to get rid of the water so you can put more in. So you just get a beaker and you undo the clip and let the water flow out of the chamber. It's really quite nice and simple. We don't like things to be too complex. If you find your specimen is too high or too low, you can press the height button here, and you can adjust the height up and down, moving it by 10 microns per sec, or 50 microns, whatever you like. We're not going to change that right now, so we will shut the height mode off. So now we're ready to mount the sample, and EMS provides in their catalog a tissue mounting glue, which is a cyanoacrylate type glue, which you can take and put on the bottom of your tissue after blotting a little bit of the excess buffer off or water off. Put your cyanoacrylate glue down, put your tissue down, hold it firmly in place for a few seconds. Then, you can put a few drops of buffer on it to keep it moist and fill the tray to the proper sectioning level, which is generally at just a few millimeters above the top of the tissue that you're working with. So what I'll do next is I will use some low temperature agar to act as a block of tissue to cut and show you how that all goes. In this segment, I'd like to talk a little bit about sample mounting, and what we'll use is the adjustable tilt stage from the 7000 SMZ slicer. And we're going to pretend that this is your mouse brain. Ideally, you want it mounted in a way that it maintains its rigidity. Well, we have some tissue mounting glue here. I'll put the part number up from the catalog. So generally what we do is, and I'm not going to glue this little piece of aluminum to the stub, is you would have the brain in buffer, and we would be working as quickly as we could. We would put a little of the tissue adhesive down, and we would mount the brain, hold it firmly for just a second or two, and we'll just pretend that it's stuck there. And then once it's stuck, what I like to do quickly is this is just some 2% low temperature agarose. I like to make different what I call blocks and dams. One of the biggest problems one encounters in cutting tissues is the ability to keep it from getting pushed by the knife if you're going too fast. So what I would do is I would glue this on the back side of the brain, and sometimes I would glue it along the sides. Some people will even embed the entire brain in low temperature agarose, but for the vast majority of people, they will not. So we will pretend that this is inside the tissue slicer and your knife is coming along and going in this direction. So, and it's oscillating back and forth, of course, and the whole idea of this is to just add a little bit more rigidity to the back side of the brain so it doesn't deflect in this direction. Remember, if your cutting advance is faster than your actual blade is cutting, you're not cutting, you're pushing. And pushing is not healthy for your tissue nor your sections. So that's why I put a little agarose backstop. This happens to be 2%. A lot of times I'll do 3% or even higher to make it really very, very rigid. And again, it's very easy to clean off. The substance is relatively inexpensive. Now I put some red food coloring in, so when we put the, we're going to cut some of this agarose in the machine here in a minute. It's just that in, clear buffer, the section is really tough to see if I leave it its normal translucent color. So I added a little food coloring to it just to make it stand out a little bit better. But that's sort of how you would set it up. Whether or not the rear part of the brain is important to you or not, you might just slice that off so there's a nice flat spot to adhere the agarose to. And that's a little bit about tissue mounting. So now I will just clean this up, dry it off, and I will put a small amount of, well, first of all, I'm going to downsize this little block because we don't need something quite that big. So I'm just going to cut it in half, and I'm going to mount that little bit if I can pick it up. I didn't bring a pair of forceps, I probably should have. And also this is why I'm wearing gloves, because I don't want to get my fingers all stuck. And once it's stuck, you can further trim it to your liking. Works best if you have nice square edges, but that's a luxury you don't get with the brain. So we're going to let that set up for a second, and then we're going to go over and mount that in a tissue slicer. As demonstrated yesterday, we set up a cutting window where the blade is at the beginning of our simulated block of tissue that we wish to cut, and the stopping point is just beyond that. The next step is to adjust the height so we can quickly get to our tissue. On the menu over here on the side, you can see that I've got the red height button engaged, which allows me to adjust how much to move the stage up or down by. And it says on the menu, load advance will be fast up or down depending on which you push. Return would be move up by 50 microns in this case. Slice would be move down. The datum height, which is its initial point, is 200. So what we will do is we will press slice. Oops, move down. We want return. So we want to raise the stage by 50 micron increments, and we just speed that up. You can always go way too fast You don't want to hack into your tissue and take a very big chunk out of it initially. I don't see the blade just beginning to wet right now. So we're going to move it upwards a little bit further so the whole knife blade is sort of wet. And since I don't have really the best lighting here, normally you would have a goose lamp or some additional lighting. We will just say that that's at the correct height. We will shut that off. And now we will let it section, and it's going to take the first slice, hit its cutting window. I'll press return because I'm not in auto slice mode. It will increment 200 microns. I'll turn slice on. And we'll make another slice. I'm going to slow the advance down a little bit. Oops. Put it into repeat mode. And now we're going to let it slice away. Well, unfortunately, even with food coloring, you can see these very, very thin, translucent sections of agarose or agar floating around in the water. As the instrument sections away, we're down to like, we've done 17 or 18 sections now. You can see them floating around in the water, I think. And we'll try to get you a better angle. I brought in some additional lighting. Normally, you can purchase this system with a light and magnifier, which you can mount on the top. So here you can see these very, very fine little sections, I think, floating around. I'll pause it for a second. It's really difficult to see at 200 microns. But they are in there, and there's a whole bunch of them. And here you can see one wrapped around the end of the stick. So I just halted it by pressing the slice button, and now the screen says press return to abort, slice to continue. So now we'll just let it continue for a couple more slices, just so you can get the idea. Now it's going down far enough where it's cutting some of the cyanoacrylate tissue glue. You can see can't see the section, but the glue separates away. But I think now is the time to halt it, because we don't want to run our ceramic blade into hard material. These will last quite some time. So what I'm going to do is I'm going to turn off auto repeat. Well, first of all, I'm going to press return to abort, shut off auto repeat, go to manual slice, press and hold load bath. So now it will lower the bath all the way down to its lowermost position. And retract the knife, and I'll stir things up here, and you can see, I think, maybe some of the sections floating around that we took. I'm going to have to maybe use some egg white next time instead of some agarose, just for better visualization. But this is the way the SMZ2, the EMS 7000 SMZ cutting system works. And what we'll do is we will attach the knife guard so we do not accidentally injure ourselves. This can be slid forward, and we can remove our specimen, and then you can scoop up and, by your preferred method, usually a camel-hailed brush works really well to pick up all these sections. And if you're using fresh brain and you're bubbling oxygen, a lot of times you'll want to remove those sections right away and get them into a more controlled environment. So now we can slide off our tray bath and clean that up. And now we would cover our knife with the handling tool. Remember that this turns the opposite direction to loosen. I put my finger on the back and I slide and remove the knife. I would rinse it in distilled waters and save it so I could use it another day. Those last quite a long time. I would just use a razor blade to carefully clean off the chuck, and then if you so desired, you could use a fine metal polish to polish that up. The tray with the ice and everything, certainly that gets rinsed with distilled water and dried. Normally I would take and remove the cutting head, rinse it in distilled water, as well as the associated screws to hold it on. I would wipe down the cutting head to make sure all the salts were off. I'd wipe the surfaces of the instrument down to remove all the salts, and then I would power the instrument down or go back to the main menu and make any changes for the next user. But in this case, we've finished the demonstration, so we'll shut it down. And that concludes our setup and operational demonstration of the Electron Microscopy Sciences 7000 SMZ2 vibrating microtome. Thank you for your attention.